As we work this limit in this example, please work it out on your own first. You're going to learn a lot more from the problem that way. And so go ahead and pause the video here and then resume it when you're ready. The first thing that we're going to try here is we need to go through this list of the nice easy ways to find a limit. And the first of those is just direct substitution. We're just going to try plugging in whatever x is approaching and see if that gives us our answer right there. So on the top then, I'm going to be doing e to the power of infinity. And on the bottom, I'm going to be doing infinity squared. Well, on the top, e to the power of infinity, notice no matter what I'm plugging in there as an exponent, the bigger the exponent is, the bigger our answer is. Since they're both going up together, that means that e to the power of infinity will equal infinity. On the bottom, we're doing infinity squared. Well, infinity times a number would be infinity. So infinity times infinity would definitely also be infinity. And so this gives us infinity over infinity, which is one of those indeterminate forms. And since it is an indeterminate form, yes, we probably will need to use L'Hopital's rule. But before I can, I need to check the other possibilities. Is there any factoring I can do? Nope. Multiply by conjugate, like a square root, would need to be involved for this to be useful. Nope. Combine fractions? No. So then yes, that means it is appropriate to go ahead and use L'Hopital's rule. So the first thing that we're going to be doing is we're going to find the derivative of the numerator and the denominator individually. So in order to write this properly, yes, I do carry down the limit. So the limit as x is approaching infinity. And I do the derivative on the top. Derivative of e to the x is e to the x. And then derivative on the bottom is 2x. Now, I actually can already tell we're going to have to do that again. Why? Because if I plug that infinity in, I already know that e to the power of infinity is going to end up equaling infinity. And because there's an x also on the bottom, 2 times infinity, yeah, it's also going to have to be an infinity. And so notice it does in fact give us another indeterminate form. You might have recognized that right away, but if not, actually plug it in like that and check. But I did still end up with an indeterminate form, so that means I do it again. I'm going to again keep the exact same limit, so as x approaches infinity, but I now take the derivative on the top and the derivative on the bottom separately. All right, now that I've done that, this is actually looking promising. I got rid of all the x's on the bottom. Let's see what happens now. E to the power of infinity, well, we've practiced that one a bunch already. That's going to equal infinity. And the 2 on the bottom just stays a 2 because there's no x there to change it. And so it's going to be infinity over 2. Well, that's half of infinity. And half of infinity is infinity. I know, fun concept, right? But that actually tells us then what the solution is. That tells us that the limit of this particular expression as x is approaching infinity is infinity.